India's next mission to the Moon. Chandrayaan-3 is scheduled to land on the Silver Globe. The Indian Space Research Organisation has launched its third mission to the Moon. The plan is to land on the surface of the Silver Globe near the South Pole. If the landing is successful, India will become the fourth country in the world, after the US, Russia and China, to succeed in this maneuver. The Chandrayaan-3 mission consists of an orbiter, a lander and a rover. She was launched into space last Friday. The landing attempt is scheduled for late August. This is India's third lunar mission. The first Chandrayaan-1 launched in 2008, but no landing was planned. Consisting of an orbiter and an impactor, it conducted the most detailed search yet for water ice on the Moon. She also made topographic maps of the surface of the Silver Globe. It lasted over a year and was an important boost to India's space program. The Chandrayaan-2 mission, which was launched in July 2019, consisted of three parts: an orbiter, a lander and a rover. The Vikram lander was to land near the Moon's south pole and launch the six-wheeled rover Pragyan from its belly to search for water and other minerals. Unfortunately, in the last phase of the flight, just before touching the surface of the Silver Globe, the controllers of the Chandrayaan-2 mission lost contact with the Vikram lander. More on this in the text. Failed landing of the Indian Chandrayaan-2 mission on the Moon. A few months later, astronomers found the remains of Indian equipment. More on this in the text. NASA found the remains of an Indian lunar lander. An amateur astronomer helped. However, the Chandrayaan-2 mission was not a total failure. The orbiter was not damaged and is still observing the lunar surface. Sridhara Panika Somanath, head of the Indian Space Research Organisation, ISRO, emphasized that engineers carefully studied the data from the last crash, fixed the faults and conducted exercises and simulations. He added that the Chandrayaan-3 mission has the same goals as its predecessor. The Chandrayaan-3 mission cost 6.1 billion rupees, about $75 million. The whole thing weighs nearly 4 tons. The Vikram lander itself weighs around 1,500 kilograms and carries a 26 kilograms rover in its belly called Pragyan, which means wisdom in Sanskrit. The craft will enter lunar orbit in about 15 to 20 days. Then, scientists will begin to reduce its speed to allow for a safe landing. If everything goes according to plan, on August 23, 24, an attempt will be made to land at the south pole of the Moon. This is largely unexplored territory. Indian scientists will primarily look for water in areas that are constantly shaded. We are more scientifically interested in this place, because the equatorial region, where it is safer to land, has already been reached and there is a lot of data available about it. If we want to make a significant discovery, we need to go to a new area, such as the South Pole, but that comes with more risks during the landing maneuver, Samanath said. The CHANDRAYAAN2 orbiter has provided many very high-resolution images of the site where we want to land, and these data have been well studied. So we know how many boulders and craters there are, added Samanath. The rover will help in the exploration of the South Pole. Pragyan is equipped with 5 scientific instruments that will allow us to study the physical properties of the lunar surface. The atmosphere near the surface and tectonic activity. We want to study what is happening below the surface. I hope we can find something new, said Samanath. The landing is scheduled to coincide with the beginning of the lunar day, which lasts 2 Earth weeks. All because the batteries of the lander and the rover need sunlight to function. Scientists have found a way to unlock the blood-brain barrier. The blood-brain barrier plays a vital role in protecting the billions of neurons in the brain. The boundary between the blood vessels and the brain keeps many toxins and pathogens away. However, its proper functioning, especially in the context of neurological diseases, is a nightmare for doctors, because the barrier also blocks the flow of drugs to the brain. Our brain is made up of billions of neurons, vulnerable cells that need protection from external factors to function properly. This task is fulfilled by the blood-brain barrier, a specialized vascular system that prevents unwanted substances from entering the brain. The barrier is necessary to protect the organ from toxins and pathogens, but it can also be a problem because it blocks access to the brain of drugs administered by researchers. For years, Scientists have been looking for a way to temporarily open the blood-brain barrier to administer drugs. Now, the team of Dr. Ann Eichmann of Yale University has developed an antibody that opens the barrier for several hours, allowing drugs to be delivered to the diseased brain and ultimately could facilitate the treatment of neurological diseases such as Alzheimer's and multiple sclerosis. We have discovered for the first time how to control the blood-brain barrier, says Eichmann. The research results were published in the journal Nature Communications. The development and maintenance of the blood-brain barrier depends on the WNT signaling pathway, which regulates a number of important cellular processes. Dr. Eichmann's team sought to determine whether this pathway could be modulated to open the on-demand barrier. The key to this process was the UNC5B molecule. It is an endothelial receptor and is expressed in capillary endothelial cells. This molecule is involved in the regulation of the exchange between blood vessels and the surrounding tissue. Experiments showed that mouse embryos lacking this receptor died because their blood vessel network did not develop properly. Moreover, the removal of UNC5B also reduced levels of a protein called CLAUDIN5, which is essential in building blood-brain barrier connections, suggesting that UNC5B may play a large role in opening the barrier. Tests in adult mice showed that the absence of UNC5B did indeed leave the blood-brain barrier open. In the next step, the researchers checked which of the ligands, i.e. compounds that bind to the receptor and send signals between or within cells, affect the integrity of the blood-brain barrier. Researchers found that one of them, NETRIN1, also caused a barrier defect when removed. In the next step, the researchers developed an antibody that can block the binding of NETRIN1 to its receptor. After injecting the antibody, the team was able to disrupt the WNT signaling pathway, causing the blood-brain barrier to temporarily open on demand. It's been quite a fascinating journey, especially the development of our blocking antibodies, says biologist and first author of the study Dr. Kevin Boget of Yale. We can now open the blood-brain barrier to deliver drugs. UNC5B has not previously been implicated in the function of the WNT signaling pathway in this way. These discoveries represent a major step forward in medical development, given their potential to treat all kinds of brain-related conditions. However, there is still much to be done. The effectiveness of the antibody still needs to be investigated. Researchers will now primarily check whether their method is safe. They will also look out for any side effects that may make it difficult to deliver medicines in this way. Because the blood-brain barrier blocks access to the brain, neurological diseases such as Alzheimer's, multiple sclerosis and brain tumors are extremely difficult to treat. Controlling the barrier and allowing drugs to be delivered to the brain may be crucial in the development of new therapies. This paves the way for more interesting basic research into how the body builds such a tight barrier to protect neurons and how it can be manipulated to deliver drugs. There is also potential to use this as a delivery platform for drugs that will penetrate the brain. Says Eichmann. In future research, the team hopes to understand how to apply their findings to the delivery of chemotherapy to treat brain tumors. Researchers are now also working to see if they can apply their antibody to other areas of the central nervous system outside